Our today's topic is on concept of field. So under the concept of field, we are going to divide the class into two parts. This is the first part of it, and under which we are going to define field and classes of field. When we say field, we mean a region or space under the influence of some physical agency. Just like when you are playing football, the moment you are inside, when you are inside the field, you will not hear whistle. But the moment you are outside, it means you are already outside the boundary. So we have gravity as its own boundary. The moment you are outside the gravity, you will not be affected by the acceleration due to gravitational force again. Likewise, when you are outside the magnetic field, so you will not be affected. So when we are talking about field, we mean a region or space under the influence of some physical agency. Then we have classes of field. We have scalar field, we have vector field. Don't forget, in the previous class or our SS1 topic, we classify classify scalar and quantity into scalar and vector. Scalar one does not have a direction. Likewise, this year we are talking about vector field. Those one that has both magnitude and direction, while scalar field has only magnitude. Example of scalar field, we have density, we have volume. We have just only quantity, they don't have direction. But example of vector field, we have gravitational field, we have electric field, we have magnetic field. Now, when we are talking about field, like I told you, we have made a region under the influence. So the moment you are within that, look at this. This is a magnet. It has its own field around it. The moment the metal is within that field, it will be attracted. But when you are outside the field, you will not feel the effect of it. This is a metal. See it? It has not reached the field. It has not entered the field of the magnet. But the moment it's already inside, it's attracting it. So because it's already inside the field, it will be attracted. Therefore, when you are within the field of either magnet or electric or gravitational field, you are going to be affected by the force. Now, we have an example of gravitational field itself. That is a region or space under the influence of gravity. Under the influence of gravity. That's good. Then, when we are talking about gravitational field, we are talking about the effect of gravity on an object. So that will not lead us to acceleration due to gravity at a place. That is the force at which the earth attracts and every object in it. So when that particular gravity, acceleration due to gravity, what are the factors affecting it? That's why the gravity of a place is different from another place. So gravity varies from one place to another as a result of some factor. And those factors are, let's say this is the shape of the earth. This line is called longitude. This is an equator. So at the center, this equator, this is latitude, the center one is called equator. This center one, this is where we have minimum value of gravity. So as you are moving upward like this, the gravity will be increasing. That is from the equator towards what? North Pole. And as you are moving from equator towards what? South Pole. The gravity also will be increasing. Therefore, the gravity has its own highest value at the North Pole and South Pole. From that, you can see that the gravity will be affected by what? By the height. By the height or depth. Then, as you are now moving away from this North Pole, the effect of the gravity on you will be reducing. Therefore, the three major factors that affect acceleration due to gravity of a plate are the shape of the earth. Because the earth is not flat, it's not perfect circle. So, as you are moving from one place to another, on the surface of earth, the gravity, the effect of gravity on you will be changing. Likewise, it also depend on what? The height or the depth from the north. From this North Pole, the depth towards the center of the earth. Then, as you are now moving away from the North Pole or from the South Pole, the effect of gravity will be reducing. Therefore, the three major factors are the shape of the earth, the depth, then the height from the North Pole. So those are the three major factors that affect acceleration due to gravity of a place. That's why our weight continue changing from one place to another. Don't forget, in our SS1 we classify the difference between mass and weight. We say mass is constant, yes, but weight vary. Not weight itself that vary, but the acceleration due to gravity that are attached to the formula of weight, because weight is equal to mg. So this one this acceleration due to gravity varies from one place to another. Automatically, the weight also will vary as you are moving from one part of the earth to another one. Now let's move to magnetic field. That is the region or space around a magnet. The region or space around a magnet. When you have a magnet like this, this is a bar magnet. Bar magnet like this. Don't forget our bar magnet has North Pole and South Pole. If this is what? The North Pole of our bar magnet, and this one is South Pole. What will happen? The line of force from here, from the north, will move directly to the south. From the north to the south. But if you just draw it like this, you have not done anything. You have to use arrow to indicate the direction of the line of force. This, then this one. So each of these is called line of force. Then this is line of force is the what? The direction. This line of force indicates direction at which a free North Pole will move if it is placed in what? In the field. The moment you place allow North Pole here, if you have a compass needle, place it here, it will point like this. That is moved from north towards south. Then you see, put one like this and stop it. Why? Why do we need to stop it? To show that this area, there is no effect of magnet there. So now to indicate, put your arrow to show that it's entering the north and it's coming out from the south. That's all. So we are going to stop. The next section of it will be what? Completion of concept of field.